one payment and she skips it for 2 months and she makes another payment. I think amazing.
See, we can look at it together. It's not that many. I guess as all the chapter 5, since there's only one assignment for chapter 5, I guess it's okay to have a lot more questions. And try not to assign too many questions. We're not doing section by section. So it's not too much. That's the question.
Yes.
So 5 times 12, 60 payment. 9% compound monthly. So it's interest per month. You're making the person. 5 years after. So if she skipped the payment, that means the money is not gonna accumulate fast enough to pay off the loan, right? Originally, if she followed the original payment plan, she should be able to pay it off by 5 years. She should have a balance 0 at 5 years. But then if she's skipping the payment, she still have a lot of money to pay by the time it's time 5 or time 60 if we talk about number of months. So if we were supposed to calculate it, we first have to calculate the payment amount P. So she's still following the same payment amount, but she had less number of payments throughout the years. So we would calculate the payment number P, because we need to calculate how many payments that she did make if she's skipping. Find out pattern in the payment time and also the actual payment amount. So we'll find out the total accumulated value that she paid off to find the final value of it at time 60, together with the loan, that the original loan of 24,000. If we put in the interest to find out the total value of the 24,000 at time 5, 5 years later. Subtract the 2 will give us the total balance, right? So let's go. Let me copy this question. This is number 10 for 5.2 homework. Okay, hello, Kyler. Hello, I think it's Melody. We're talking about one of the homework question, 5.2. 5.2 deal with loan payment, amortized loan payment. So question to talk about, if we skip payment, how would that affect the outstanding balance when the time is due? Right, so here, try to label them the loan amount. Okay. All right, so the loan amount is 24,000. And it's being paid for the time is 5 years, but we're getting 12 payment per year. So the total number payment is going to be 5 times 12, that's 60 payment. So if we're paying off the loan with 60 payment, the loan was taken out at time 0. So the total present value of all future payments should be the 24,000. So we would set up the equation saying that the 24,000 is equal to the P. We're calculating value for P. P times A is the present value calculation. P times A 60. We got 60 in here. Easier to make it a little bit smaller. A 60. And we also need to know the interest rate if we want to calculate the A value. In this question, it said that the interest is 9% compounded monthly. So the actual interest is going to be 0.09 divided by 12. We should be able to find out that value to make it easy for the calculation. And it's 0.0075. Okay, now let's calculate the A. So based on this equation that we have here, P would equal to, grab A. And copy my time so I don't mess up the time. 24,000 divided by A. What is A? A is 1 minus 1 plus I, the V to the power n, which is 1.0075. It's negative power. The number payment is 60. So that is numerator in A. And this has to be divided by the I. But since the A is in the denominator, the I should be multiplied. I is 0.0075. That will be the calculation for P. Okay. And so normally we will round it to 2 decimal. I wonder if we should round it now. That's how much payment it is. Roughly is $4.98 and 20 cents. So with that calculation, we end up having P equal to this amount. I do have to look at the timeline to say if we skip 2 payment, how many payment that she actually pays. So let's try to draw the timeline. Overall, the original plan was paying, like this is 1, that was 60. There were supposed to be 60 payment totally, and this is the initial, that was a 0. But she skipped 2, so she was supposed to pay per month. Then there's no payment at time 2, there's a payment at time 3, and there's no payment at time 4, and then there's a payment at time 5. Let me see. She has a habit of skipping 2 monthly payment after. So my perception is wrong. So she didn't pay the 2 and 3, she paid at 4. So that's the right. So she will pay the amount at P and then skip 2, and then there's 4. And then they're skipping 5 and 6, and then we move on to, so I'm trying to identify the pattern. To 7, there's another payment, and then 8 and 9 will be skipped, and there's a 10, and there's another payment, right? So how many payment in total that we are expecting? The time for the payment looks like a arithmetic sequence: 1, 4, 7, and 10, right? Overall. So what kind of payment, if we think of it, the time of the payment as a arithmetic sequence, what was the last payment? So we would get, let me try to write an arithmetic sequence. It would equal to AN equal to, the first one is 1, right? 1 plus, the increment is 3, right? 1, 4, 7, the increment is 3. And then 3 multiplied by n minus 1. Okay, and then we simplify that, it's going to be 3n minus 2. That way when n equal to 1, the 3 minus 1 is 1. So that will be the formula for the arithmetic sequence. And we know that the final time is 60, so he's not paying, we're calculating the value at time 60, so we're not looking at any payment after 60. So we're gonna try to find out how many payment are we talking about. This is less than 60. I really tried to find the total number of payment. We could just go 60 divided by 3, which will end up getting 20 payment. I want to see if that's true. It should pay 20 of that amount, or is it anything less? So if 3n minus 2 has to be less than 60, the 3n is less than 62. So the n is less than, we cannot go over, so we're going to take a number, we will run down from it. So it's going to be 60 divided by 3. We have 62 divided by 3. It's 20. So it is 20 payment. Okay, so so she is paying 20 of those payments. So she is less. I mean, the final number of payment is 20 payment. So now we're at the time we have to find out the total accumulated value. And let's see what's the last payment. If we're fitting this, the last payment is when n equal to 20. 3 times 20 minus 2. Try to type the last payment. 3 times 20 minus 2. I'm doing the 3n minus 2. Which then equal to 58. So the last payment occurred at time 58. And obviously with the same habit, there's no payment at 59 and 60. But we're trying to find the value at time 60. So we got to find the cumulative value of all these payments. Now, if you're taking the P multiplied by, we're accumulating, so it's a formula S. So we're gonna calculate S20 because the total number of payment is 20, the way she is skipping. The 20 payment, and now we want to find the actual interest rate involved in the payment. Okay. If we're using if we're using S formula, we're doing annuity immediate formula. So the calculation this way will only give you the actual value at time 58. And you have to multiply such as 1.0075 interest rate. This is it's not right. That's the monthly interest rate, right? We there's 2 months, it's monthly interest rate, that's right, to the power 2. So if we do calculate P time S20, then we have to let it grow until time 60. That's why I've multiplied that one. Are we okay there? We still have a little bit of problem, even if we want to calculate the total cumulative value of P time S20, we have to find the proper interest rate for it, because the payment is not a monthly payment. So in between payments, the interest rate is not going to be, 0.0075. So we have to look at the proper interest rate. Let's call that J for the 20 payment, that increment, the interest rate is different. So what happened, how we have calculated J, it's going to be a 3 months interest rate. Your 1 month interest rate is 0.075. You delay the payment until 3 months later. So 1.03300 to the power 3. Try to write a 3, it just won't do. That is the growth factor for 3 months. And then we minus 1. That's the actual value for the J. Are we okay there? Just trying to find the 3 months interest rate. So now we can calculate the total accumulated value for P. All right, let me I type it in here because it's obviously a lot easier to type in the text format. So this was the payment of 498.20. Now this same payment 498 0.20 is being multiplied to a total accumulated value of, it was supposed to be 1 plus j to the power of 20 minus 1. That's the S formula divided by j. That's the S20 that we were supposed to calculate. Now, and then this has to be multiplied by 1.0075 to the power of 2. That is how much value all those payment is at time 5 years later. Now we have to pay attention to the J here, because if you want to finish your calculation, you need the J. So what was the J relation? J is equal to 1.0075 to the power 3 minus 1. That is saying that J plus 1 would equal to 1.0075 to the power 3. Therefore, when you are calculating the 1 plus J to the power 20, you are really calculating 1.0075 power 3, and then there's power 60. So the length of it is still kind of like the 60 months, because the time frame is 60 months, right? The whole thing. So that's with that one being replaced. And then of course, J itself was like fit that formula back then. Let's actually fit in the number for the computation. So this one is being replaced by the 1.05 to the power 60. That's that one. And then J is this number. So we have to replace the J by the proper value of the J. And that should be the total accumulated value for all the past payment. And their total value is. Please let me know if there's a question or problem if I lost track of the. That's the accumulated value at time 60 of all those payments. So we're gonna take that. That's the payment that she made. All right. So then time 60 months value of payment. And also she owes money. The original low amount we want to calculate is total value at time 60 as well. It was the 2400. We want to calculate what is the value at time 60 as well, because we want to find out time 60. It would use time 60's balance, right? Up to the power 60. So this will give us how much she owed on the loan, future value of the loan. So now we have this. These two supposed to be subtracted. Right, the payment should be subtracted out of the original loan, right? Loan payment subtracted out of the loan balance. That should be the outstanding balance at time 60. I hope this works out. Let's see. Putting this number and subtract the actual payment that she made through all the years. She really didn't pay a lot, but it's still roughly 1/3 of the total balance that she owes. So that looks like the solution for question 10. We okay? So there's a little bit of detail here and there. I think it's easier to trace this calculation way back there. But overall, you would have to find out where was the last payment, the time for the last payment, and let it roll 2 times 60. And also when you try to calculate the total value of the payment, you find out the actual mine is skipping 2. You may have skip 1 or skip 3, and the total value would have a different interest rate than the original interest rate. Is that okay?
I didn't have the part at the end where you multiply for the last 2 years.
Oh, okay.
I mean, last 2 months.
So the rest was okay. It's the last 2 months. Well, you also have a situation with 60 months and then skipping to the rest of the same. I mean, we may.
It was skipping 2 months, but it had different interest.
I see. Okay. You can work out your version and see if we're able to fix it. Okay. Now, any other homework question? We're talking about the question 10 on 5.2 homework. Any other question? If there's no other question, I'll continue with what we were talking about with chapter 6, and we're talking about loan payment. We were way last. We're moving on to section 6.5, and let's start from 6.5. So 6.5 is a focus on book value. Book value is the kind of like the outstanding loan balance, but it's on the bond. So if you purchase a bond and bond will guarantee a certain cash flow along the timeline, those cash flow, you want to be able to identify its future value. That will be kind of like the book value based on the following payment and the final payment. All right, so we would want to determine something called a bond amortization schedule based on the book value. So the book value and your amortization schedule are not the same thing, but it's highly related. So let's start by defining and talking about the book value. This is something we have already went over, but I'm going to repeat it again. Now, what's the book value? A book value is the balance of the debt at time t immediately after any t coupon payment, the time t coupon payment. So it should be calculated right after that payment is made. For example, B5 represent if you right after you pay you're receiving your fifth payment, what was the balance? Okay, so B0 equal to P, because if you haven't paid any coupon yet, and then what do you owe is what you paid. So the bond, the price that you pay for the bond is the book value at time 0. The final payment is C. So if you had the N coupon already being paid, and then at time C is the exemption. When the bond mature, the final payment is C. The redemption payment is C. So BN equals C. So what about in the middle of it? And it really kind of related to the relation between P and C. If we talk about the premium and discount, if P is higher than C, then P is higher than C, then we're purchased, sell at the bond is sold at premium. So your B book value function BT would be a decreasing function. It decreases from a higher value P down to a lower value C. Now, if the P is less than C, then the book value grow from P onto C. C will be the last payment. So that is when the bond is sold at a discount, right? So the book value has a lot related to the relation between P and C. Now, in between the changes, so this function, the change of this function in between, we have a couple. Suppose we have a couple of payments. Now, if we do not have any coupon payment, there's no payment before the initial price and the final redemption price, then it will go directly from P to C. Then C should equal to the future value of P if there's no coupon payment in the middle of it. So that would be a simple case. Like then the relation between P and C fits the relation that we had in chapter 1. Basically, it would be P times the V to the power N, which we put a C. So then, well, the other way around, C times V to the power N equal to P. P is a present value. Anyway, so, but somehow we are talking about when we do have coupon payment. So suppose we have N coupon payment, then for every coupon payment, you have to consider how much interest is being paid and how much principal is being paid. So here we have the formula. The interest payment is the previous book value multiplied by the interest. That's your IT. IT is the interest in the T's payment. That's how much interest is in the T's payment. And then the PT. PT is calculated by BT minus 1 minus BT. So if we have a bond that is sold at a premium, that is P is higher than C. In that case, then BT minus 1 is higher than BT. So PT actually is calculating a premium, right? Higher value minus a lower value. And that's called the amount of adjustment of the principal, kind of like the principal payment in the loan payment amortization plan. But PT also indicated that if P is higher than C, PT is calculating the premium at that in that particular payment. All right, back a little bit review of the formula we talked about in 6.4. It's called the premium discount formula. This first one is applying the basic price formula because at time zero, remember at time zero, the payment will be the coupon payment that still needs to be paid, all the future coupon payment plus the present value of the final payment. So the redemption of C multiplied V to the power N plus the FR times AN. That was the basic price formula for the bond price. We apply the same formula to calculate the book value. So the top one, 6.5.4, is giving us the book value formula using the basic price formula. Right, with the premium discount formula, you can calculate the same thing. In 6.4, we have P equal to C times G minus J times AN plus C. But now we can do the same for the book value at any given time. Except the future number payment is no longer N, it's N minus T, because BT represent the balance or the book value when you have paid a T payment. So T coupon has already been paid. The total number payments of coupons supposed to be N payment. So N minus T will be more coupon to come in the future. So the second formula represents a premium discount formula. Any questions? All right, so we're going to use the BT formula, the second BT formula to find out a way, like a standard way to identify the formula for IT and formula PT. Now IT equal to J times VT minus 1. So we're gonna replace the T with T minus 1. I actually prefer using the basic price formula. You can use both. The one with the problem with the premium discount formula is you have to calculate J and then G and J. So C times G minus J will be one of the key factor in the calculation. You multiply AN minus C plus 1 and then plus C. Then this is our VT minus 1, and you multiply by J. That's your I. Now the J is in the denominator of the AN, so in the A formula denominator J. So this J cancel that J, and that will make the formula a little bit more concise. And then finally, combine the like term and distribute the number. We get this last formula saying IT is equal to CG minus C times G minus J times V to the power N minus C plus 1. So that kind of is an interesting formula to say, because you see CG is actually the coupon payment, the number, the quantity of coupon payment. So IT equal to the coupon payment minus that part. And then we remember that IT, in every coupon payment, some payment is for the interest, some payment is for the principal, right? That gives us the idea that if the CG minus this is the interest, then this part, the one that is being subtracted, that must be the principal, the PT. So give us a formula to handle the PT. And we can certainly come up with a formula for PT. The other way around, if you got a formula for BT, you got a formula for BT minus 1. By definition, PT equal to BT minus 1 minus BT. So we subtract these two, the first two formula, we have a formula for PT. And then there are a couple common factors subtracted. C minus C, they goes away. And then the rest of them, A and then minus C plus 1 minus A and minus C, we got that discount factor, V and T. With V to the power N minus C plus 1. So that will be the formula for PT, which is exactly what we have over here. And that kind of confirmed with the perception that IT plus PT equal to CG. Any question? So to kind of echo what we were talking about in 5.2, that in every payment, there's the payment for the interest, there's payment for the principal, the payment for interest and principal added together, that's the total number payment. Any question? So this gave us some general idea of the computation, right? And this is a graph of the two scenario. This is the bond sold at a premium, so it start with P, decrease down to the price, the value of C. And this is the bond sold at a discount, so start with P, increase all the way up to the C. This is when we have premium or discount. All right, and we talk about the PT. Sometimes they have the special name. If the bond is being sold at a premium, then every PT is kind of like a small amount of those premium. The total premium is P minus C. All right, and then PT, of course, is not the whole thing, but it's like the book value is descending down to C little by little. So in PT is the amount for amortization of the premium. So you kind of cutting the whole premium into small pieces in time T. That's that part being paid in that payment. I hope that kind of makes sense, but it gives a special name to it. Now, on the other hand, if the P is less than C, so you have a discount. So then in that case, the negative PT, because PT is going to be negative, so negative PT is positive. So that part, the difference, that part is called the amount for accumulation of the discount. So we have an amount of accumulation for the amortization for the premium or amount of accumulation for the discount. They pretty much mean the same thing, which is essentially the quantity, the absolute value of PT. All right, so then with that, we can start coming up with the amortization table for the book value or for the coupon payment, for the bond payment. So all the coupon payment equal to the same thing. They are FR equal to CG. So the CG is over here. C is the redemption amount and G is the modified coupon rate. So these are all related to the coupon. So in the coupon payment column, they're all identical. And then remember PT equal to CG minus the PT, and PT is that power function, C times G minus J, V to the power N minus K plus 1. Right, we have to identify there's this opposite relation here. The earlier the time, the more payment in the future. So at time 1, 2, 3, we have a higher power in the Vn minus 1. And then the power for the V gets smaller and smaller because the payment is getting less and less. The future payment that is still to be paid is less. Any question? It's kind of useful to see that IT and PT have a general formula, but I don't use this as often because I feel I don't want to go all the trouble to calculate the G, but it is a more of a general formula for IT and PT. All right, I think this is where we stopped. Okay. So let's look through the example on 6.5. This is talking about interest principal allocation. I think this one we went over before. All right, as you can see, when we're trying to look at the study bond, and it's very important to identify some of the key terms. Like this question is talking about 6 a year, so that N equal to 6 years term of the bond. 1,800 is a face value, 8.5 is a coupon rate. And then it says semi-annual coupon. That means in every coupon, the coupon rate is going to be 8.5% divided by 2. About for the price is given, that's the P. Redeemable for 1860, that's the C. So the ability of trying to identify these information and quantify them with the proper notation is very important. After reading the first sentence, we start labeling all these out and then kind of see how they're being calculated. All right, and then now that we know the coupon rate and then the coupon rate alpha divided by 2, M equal to 2, it's the actual coupon rate that we call R equal to alpha divided by M. And then we can calculate the number of coupon payment. This is a 6-year payment. The question is to find out the amount for amortization of premium at the end of 2.5 years and the interest at that time. So if you read the question is to calculate PT and IT for time 5, right? 2.5 times 2, that's the 5 payment later. Any question? Okay, so the total number payment is 12 because it's 6 years, 6 times 2 is 12. Out of 12 payment in the whole timeline, we want to know exactly what was the interest and principal at time 5, like after the 5th payment. Okay. So now what we're gonna do right now is if we want to calculate PT or IT, we have to be able to calculate the balance. The entire question is missing one piece of information. That's what's the yield rate. We don't know the interest rate per year or per month. Nothing is mentioning. The only rate is the 8.5. That's the coupon rate. So we kind of have to use all the given information to find out the rate. So here we have the price is given and the coupon is 76.5. The final redemption amount is 18600. So with all this, so basically the entire timeline, cash flow is clear. The only thing we do not know is interest. We put in the I, and now all we have to do is use our calculator or use a finance calculator to figure out the interest rate. That's normally I call it J. Any question? The monthly interest rate we call it J. Well, semi-annual interest rate we call it J. The I not only represent the annual effective interest rate. The capital I was the nominal interest rates. Those are the terminology. I think last time I was doing this. All right, we were supposed to solve the equation J here, and then I was thinking maybe we can. Okay, maybe we can set it into an equation and solve the 0 for that equation. I did a little bit of exploration just to indicate how it's being calculated. And I end up having, like, if I search it this way, I don't know when there's going to be a 0, right? I plug in different number just to say when would the f of x equal to 0, because the number that make it equal to 0 is supposed to be the interest rate, but it's taking forever. So maybe I should do a Newton's method just so it would speed up the process. As a numerical solution to an equation, Newton's method is way faster than what I did is plug in number. This is kind of like an intermediate value theorem, because if you see numbers, some large, some small, but eventually as you get closer and closer, there's 2. If I slowly change it, it will get get closer and closer to 0, but the process is not fast enough. But once you get close enough, you can do a Newton's method. I try not to stop, like if I try to do Newton's method when the x equal to 0.01, it's going to be all over the place. So you want to see the tendency. That's why you should do the Newton's method when you know you are close enough. Okay. And then that will be the interest rate I find out. And then using the interest rate, once we have the interest rate J, we can calculate the I5 and P5. I picked the solution 2 in the book, posted here because to me it's more intuitive. There are solution 1. The solution 1 was using the say G minus J and then AN, that kind of formula. But I did B4, the book value at time 4. That means after you paid 4 payment of the coupon. So out of 12 payment, the 12 minus 4, there's still 8 payment in the future. So what we can do is to find out the present value of the future 8 payment of 76.5 plus the present value of the final payment. And that will give you the book value at time 4. Okay. Now at time 5, you have to pay the book for B4 is like outstanding balance in the last time period. So at time 5, the interest you were supposed to be paying is taking that. We find out J. J is the solution for the equation. J multiply the outstanding balance in the last period is how much interest that we were supposed to be paid at time 5. And then since the total payment is 76.5, you subtract the interest, you have the PT. That would be the amortization of the premium. Any question? Right, so P5, so essentially we're supposed to calculate I5 and P5, but if you read the original question, it sounded very formal and difficult to understand. When people just outright say, find the amount of amortization of premium, that sounds very, very formal. It's a little difficult to understand. That's why we try to define the term before we go ahead and calculate it. So that will be the solution for this question. This is how do we use a BA2 plus calculator. All we have to do is put in number payment is 12. The present value is negative 1,918. The payment amount is 76.5, and the future value is 1860, and then you calculate the interest rate, it will give you the exact interest rate. So for the interest rate calculation, since the cash flow is very clear, calculator does a lot better than what I did with all the Newton's method calculation. Any question? And then the calculator has a amortization schedule. You press second AMOT, then go to time 5, go 5 and 5. This two, 5 enter and an error, 5 enter and an error. They give you the beginning time and final time, right? And basically you're beginning at time 5, ending at time 5, and then you basically focus on time 5. And then you press the arrow to find out this is a PT and that is a IT. So the table itself, it gives you the amortization table for the whole payment plan. Any question? So if we use it well, the calculator save a lot of time if we're clear about the cash flow. All right, next example, we're talking about amounts for amortization of the premium. Okay, so if you read the question itself, it sounds like some calculation of PT. So let's see the question. Again, one of the main thing is bonds are very similar to the annuity and the loan payment that we studied in chapter 5. But the thing is, often bond have a variety of different scenario, and also the term seems to has more than what we were doing in chapter 5. So a 12-year bond with semi-annual level coupon is bought at a premium to yield 7.5 convertible semi-annually. So the good thing is the interest rate is given, but I don't see a coupon rate. So when we're reading the first question, it's 7.5 a coupon rate or a interest rate. So I think we're not given the coupon rate, we're given the interest rate for the actual interest rate, yield interest rate for the cash flow. If the amount for amortization premium in the force to the last payment is 8.02. So that sounds a little bit tricky. What do we mean by the force to the last payment? So if you got end payment, and then the last payment will be the end payment, right? The first to the last will be n-1, n-2, and force to the last n-3 or n-4, right? That's the indication. So I think it's the amount for amortization premium, the PT for that time points. We have to find out the T equal to what? Find the premium and the total amount for amortization of the premium in the first 3 years. So the premium, when we talk about premium for the entire bond, the premium should be P minus C. Are we okay? And then the total amount for amortization premium in the first 3 years. It was talking about semi-annual coupon payment. In the first 3 years, how many coupon payment? There are 6, right? Every half a year, so 3 years, 6 payment. We want to find out the total amount of premium. So we want to calculate P1, P2, P3, P4, P5, P6, right? The summation of the 6, right? After we read the question, we start trying to label things and then trying to see what's given. A 12-year bond, and it was semi-annual payment. So there we have it. And then we have the interest rate with 7.5, and then we have J, which is annual, the nominal interest rate is 7.5, convertible semi-annually. So we divide by 2, that's 0.0375. Are we okay so far? Right, it did say it was bought at a premium. So that is only indicating that P is higher than C. It doesn't give any other information. All we know is it's sold at a premium. Any question? So I'm reading the first sentence. Label out what is the first sentence is telling me with a mathematical formula. And then, okay, so on top of it, now that we know, and it's 12, 2 payment per year. So the total number payment is going to be 2 times 12, that's 24. And it says, so we get total 24 payment, 24, 23, 22, and then 21. The fourth to the last should be the 21, the 21st payment. So it says the amount of amortization of premium is 8.02. Okay, so the 8.02 is P21, but it's the actual payment is still should be F times R, right? Right? It's supposed to be F times R. We don't even know the F. And so there's a lot of difficulty in this question. We don't know the face value. We don't know the redemption price. We don't know the coupon rate. There's a lot of missing information. All right. Then that's the second sentence is telling us P21 equal to 8.02. We want to find the premium, which is supposed to be P minus C. We also want to find the total amount of amortization of premium in the first 3 years, which means we want to find the summation of the first 6 PT, which is the principal, the premium. Right. Okay, so let's try to simplify the question a little bit. According to what we learned before, what is PT? PT equal to BT minus 1 minus BT. So for example, B1 equal to B0 minus P1 equal to B0 minus B1, P2, B1 minus B2, P3, B2 minus B3, P4, B3 minus B4, P5, B4 minus B4. So you can see the whole thing come as if you are trying to find the total of it, we really don't have to find each one by one because many of them seems to be canceling each other out. Are we okay there? So essentially the B1, B2, B3 are all canceled. So all you have to do is calculate B0 minus B6. So we should only care about the book value of 0 and the book value of 6. But book value of 0 actually equal to the original price, which what we call P, right? Are we okay? Right, so I'm trying to slowly analyze this if it's a thinking process. All right, so now we're gonna try to see the single important information is P21 equal to 8.02. So I want to figure out if that, how much information does that carry? So I pull out the formula for PT. From the previous content, we have a formula for IT and PT. And I try not to use it as much because this to me, it's actual formula we gotta follow. So PT equal to C times G minus J, V to the power N minus T plus 1. So now what we're looking at is N equal to 24, the total number of payment is 24. The time that we're looking at is the 21st payment, T equal to 21 and equal to 24. So we fit all that into the formula. If BT fit that formula when T equal to 21, P21 equal to C times G minus J, V to the power 4, and that equal to 8.02. We got that. All right. So then we realize that this thing is not giving a whole lot of information. We already know the V. V is 1.0375 to the power of -4, right? V4. But then you can move this over to the other side. Right? V is a negative power, but if you multiply both sides with negative of the negative power, it's positive power. So we can see that C times G minus J can be calculated just from the PT information. Right? We don't know the J, we don't know the G, we don't know the G, we don't know the C. But we can now certainly have something to hold on to. So it does give us like a combined information. Are we okay so far? All right, and going back to the premium. Premium equal to P minus C. Remember P was equal to C times G minus J, AN plus C. So that was the premium discount formula that we learned in 6.4. So now we realize if we already have a number for C times G minus J, all we have to do is multiply AN. So I end up calculating the AN. 8.02 times 1.0375 to the power 4 is the first part, and then multiplied by AN. AN, we have no problem. We already have the interest rate. That was 0.0375. That is the power I. And then that's 1 plus I, raise it to the power of -24, since we got 24 payment, divided by the I. There we have it, P minus C. Any question? So that means the price is higher than the redemption amount by 145.38. That's the total amount of premium. Any question? So now we're gonna look at the book value. This answers the first question, how much is the premium? And then now we're gonna find the book value. The book value calculation, we follow the formula. How do we calculate B0? B0 equal to P. How to calculate B6? B6 equal to, this is a second formula for book value is C times G minus J A18, because if you, what's B6? So B6 is when 6 payment has already been paid. Out of 24 payment, 24 minus 6, 18 payment in the future. So C times G minus J times A18 plus C, that is B6. All right, and then because of subtraction P minus C, that part we already knew, that was a redemption amount, we calculated at 145.38. And then the other part, we already knew the formula for C, we know the number for C times G minus J. So that's the information we get from P21 is applied again. So then we have the final answer for the total premium. Any question? Right, so this will be one of those situations where you only have a partial information. That information actually brings out a lot of insight on how things can be calculated. And that finished this question. Any question? So that's this example. So you can see combining the scenario and the cash flow, we can understand a lot about the even when the information are not entirely clear. Okay, so this is a example number 15. We have the focus is on amount for accumulation of discounts. Right, if the previous question was focused on the premium, this question is when the bond is sold at a discount. So we have a par value. Par value means a redemption amount equal to the face value. So the face value is 10,000. The redemption is also 10,000, and it was sold for it's bought for 9,562. Obviously lower than the 10,000, so we know that's a discount. We have par value, so we know the redemption on 20-year 14% bond with annual coupon. So that when you see 14% bond, that 14% is a coupon rate. And find the accumulation of discount in the third coupon. So when you see accumulation of the discount, that's PT. In the third coupon, so we intended to calculate P3. Are we okay? So when you have discount situation, you calculate the accumulation discount. When you have premium situation, you calculate amortization of the premium. The terminology is kind of weird, different in the two situations, and the amount of interest for the third year. So essentially, we got annual coupon, so it's 1 coupon per year. For the third year, it's the third coupon, third payment. So we're trying to find out in the third coupon payment, how much is the interest, how much for the other stuff, right? So let's look at how much we know. We analyze the information given, got our face value and the redemption amount that's actually equal to C equal to 10,000. 20 years equal to 20. Coupon rate is 14%. Annual coupon M equal to 1. So then the R equal to alpha over M. So that was 0.14, and then the price is 9,562. We want to find P3 and I3. I'm trying to write everything into the language that's how we normally talk about bond. Any question? So when things are more systematic and organized, it's easier to handle. That's kind of the reason we added so much stuff. So notice the yield rate is not given, so we need to calculate it. There will be the problem. So we have the price of the bond equal to the present value of all the future cash flow. So then first is the face value multiplied by the coupon rate. That's the quantity of the coupon multiplied by A20. It's a 20-year payment, 20 coupon. So that was A20, which is 1 minus 1 plus I to the negative 20 power over J. That was J. Plus the 10,000 times 1 plus J to the negative 20 power. So this all the future cash flow present value is the bond price. All right, with that equation, we were supposed to solve for the J. Any question? Right, and then there's a solving part. All right, this is how I solved it. I actually did a Newton's method. I was putting in 0.14 to it and put 0.15, and there one positive, one negative. So I know there's in between those numbers. So what I start with 0.15 and minus the value of 0.15 divided by the derivative at 0.15. And that was the updated value. And that's not quite as accurate. So I put it in again and minus the function value at 0.1468 and divided by the derivative. And that's updated a little bit more. And I still see the numbers negative 3.4 is not zero. So I did calculate the value of a function, which ended up being pretty close to zero. So negative 0.001 is the function value. Negative 0.001 is almost zero. So it's being accurate at up to 2 decimal already. So I ended up getting that final number. I think that's close enough. So pretty much I was trying to use Newton's method on this, but of course you can also use your calculator. And this is also another situation when the cash flow of the coupon and the final redemption amount is very clear. The price is clear. So the price should be your present value should set that into a negative value. And then we have the, it should be 14,000 to be the coupon payment, and then the final payment is 10,000. So with the cash flow put into the calculator, it should be able to find the interest rate. So anyway, once we find the interest payment, and now it's time to do the calculation. Now, according to what we're talking about, if you want to calculate I3 is the interest rate in the third coupon payment. That means there is already two coupon already paid. You will calculate the B2 multiplied by the interest rate. The interest rate is the one we just solved. 20 payment, you have to have already paid. There's a future 18 payment. So calculating B2 is not too far from B0. B0 is a bond price. So I guess B2 is not that small. The coupon payment multiplied by A18 plus a 10,000 times V to the power 18. And that allows us to figure out B2. B2 multiplied by the interest rate that gives you the I3. The total coupon is 1,400 minus the interest. That's your P3. You can see P3 is negative. That's the reason. The reason it's negative because the function is a increasing function. So we're making a small number minus big numbers. That's why it's negative. But the amount of the discount is the positive 5.82. It's the whole calculation. So IT and PT, you only have to calculate one. I don't want to go through the trouble to calculate the G and C. So but it's possible to do the other formula. So the I3 and PC, there are two formula that we can follow. I went by the basic formula. Any question? So the textbook may have more solution. I use this one. All right, this is how we do it with a B2 plus calculator. Put in n equal to 20 and a present value equal to negative 9,562. The future value being 10,000, payment is 1,400. Calculate the interest rate. With the interest rate, go down to the amortization plan and having the 3 being your initial and terminal time spot, and then it will give you the P3 and I3 in the calculation. So everything will work out exactly if you are using the calculator. Any question? Okay, so that's that example. Let me see if we got time. Okay. So the next example talking about the relation between the book value and the price of the bond. So here we have the N-year, 1,000 par value bond with 8% annual coupon has a annual effective yield of I. See, I is not given. The book value of the bond at the end of the third year is 990.92. The book value of the bond at the end of the fifth year is 995.26. Find the price of the bond. You can notice that the book value is increasing. So I'm guessing this is a discount. It's the bond is being sold at a discount. That's why the book value has been increasing. Okay, so we want to find the price of bond. That means you gotta find out. And we really know very little. We have the par value, which means the redemption amount is going to be 1,000. So F equal to 1,000 equal to C. 8% is a coupon rate. So 1,000 times 8% is $80 coupon payment. Well, the thing is, we don't know the end. It's the end year. What was the end? We don't know. So there's a lot of missing information. That's also why we were giving more. So a lot of other information, but not the key information. We don't have the yield rate. We have the bond rate. We don't have the yield rate. We don't have the price. We don't have the number of years. Okay. Any question? Are we okay so far? So now, so I put in all the information we can identify from the first sentence, and then we're gonna look at the price that we want to calculate. If we're calculating P equal to, using the basic price formula, P equal to FR times 1 minus A, FR times AN, they're all AN formula, and then C times 1 plus I. It's annual coupon, so I and J are the same thing. So 1 plus I to the power negative, and that's the P calculation. As you can see in this formula, we know the F, that's 1,000. We know the R. The R is the 8%. We don't know the J. We don't know the N. So from that, we realize that if we're calculating price of the bond, we've got to calculate N. I got to calculate annual yield rate. It's going to be a little bit harder. So consider everything else is already given. The information that we did not use is a book value. So we're going to try to look at the connection between the two book value. So here we go. Now, according to the book value formula, we were looking at, that's how I was analyzing the book value. B3 equal to 990.92 is when you have already received the three coupon payment. So the total number of coupon is N. You were paid 3. So how many coupon to be expect is N minus 3, right? Number of coupon in the future payment. But this is supposed to be negative N. So instead of N minus 3, we have 3 minus N. There's 3 minus N in their coupon because those 3 that's already paid. So this first formula is a formula for B3. With a similar setting, the formula for B5 is when you have 5 payment of the coupons already done. Then the total number payment is N. N minus 5 is future payment. So when you discounted, the power is 5 minus N, the discount factor. So that's the formula for B5 and B3. So this is really how I solved it. It's different than the book. The book have a different reasoning. Maybe the book was a little easier. But when I was looking at book value, how do I do it? I will look at the book value relation. And then I realized if I want to find out, like solve N and solve I, technically we have a system equation which have N and I in there. So we're solving 2 variables from 2 equations. So it's possible to do it. So I started trying to think about how do we solve it. If we're going to solve the variable from 2 equations, we have to eliminate variable, right? We have to find a way to eliminate the variable. So the first variable I want to eliminate is N. So the first equation had power 3 minus N, the second has 5 minus N. So I wanted to multiply both sides of the equation. In the first equation, multiplied by 1 plus I squared. So if you multiply 1 plus I squared to both sides of the first equation, we're getting this. Okay, and then the power 3 minus A become 5 minus N. And this multiplied that's also 5 minus N. Are we okay there? So after that, we can do subtraction. You can take the first equation, subtract the second equation. So I'm displaying the subtraction on the left side. Now the subtraction on the right side is more extensive. You see the C will be canceled, right? We don't know the C, so it's better that we get rid of it. These 2 equations have 3 variables. They have I, the N, and the C. So if we subtract the 2 equations, we get rid of the information about N and also C. After subtraction, what we have is here. Any question? The power AB over I, 1 plus I to the power 5 minus N, they were canceled. The only thing is left is the first term in both of these equations. All right, and then the solving part. We want to solve this. Right, pull up the last equation and start analyzing it. And then the one on the left side, I expanded the 1 plus I squared. The one on the right side, it was the 1 plus 2I plus I squared. So there's a 1. So we have 80 over I, 80 over I. That was definitely canceled. And the rest of them, because we divided the I squared, canceled that I. So then we end up having an equation that's equal to. Any question? The rest of them is combined like term and start solving the equation with a production formula. That's what I have. Any question? So that's the solution for the interest rate. We finally have our interest rate. In the textbook, it had a different approach. In the textbook, think about B3 as the book value. And then there are relations between the book value at 3 and book value at 5. And then this is a relation here. Basically, the value at B3 is the total present value for all the after you pay the 3 payment. Now the value at B5 is the total future value after we paid 5 payment. So I think it's the equation, the time 5 value of the cash flow. Okay, I guess we can draw a line to show it. This is how the textbook is doing. It's more of a analysis of the cash flow. So it's different than what I was thinking about, but it's not. Right. So what we have is, if you draw this timeline, it's a little easier to understand. We come up with that equation. I felt like I completely understand it yesterday, but now I'm going to maybe analyze a little bit. So 0, and then there's a 1, and there's a 2, oh, 2, and then there's 3, and 4, up, and 5. Of course, there's more payment after that. So basically, we got coupon payment at all these spots, and then let's call that FR value. Okay, and then there's a final payment of C. So what happened is when you are calculating B3. So what's B3? B3 is the all the future cash flow plus the C. Their total value is at B3. Okay. And then what happened to B5? B5 is calculated right after the 5th payment is paid. All the future cash flow and the final C, that's B5. So what would be the difference between B3 and B5? You will have to, the B5 is your value at B3. You let it roll for 2 time period, and that's the B3. And then you're going to take away the payment that you paid. At B5, you are paying, this payment is actually 80. So at B5, this is an $80 payment, and that's $80 payment. This is the B5. Okay, so the B5, you want to subtract the 80 that's already paid, and also subtract the this $80 times 1 plus I. So these two is take away those 2 payments. So take away those 2 payments, and then the future value of the B3 would be multiplied by 1 plus I. That's equal to B5. So it's a little bit about the relation between B3 and B5. Any question? I hope that kind of makes sense. So your present value at B5, which will equal to, suppose you let B3 last until here, and you take away all those payments there. So B5 is how much future payment that we had. Because when you were calculating B3, you had all these payments in, but B5 only considered all the future payment after the fixed payment. So these two have to take away, because B5 really do not include those 2 payments. But B5 does include all the rest of the payment in B3. Any question? All right, so this equation does make it a little bit easier because you have B3, which equal to, so you fit all these numbers in there, This is the B3 equal to the 990.92, and those are a direct copy over. The B5 minus 80 will equal to this number. So then you end up getting a degree 2 equation about 1 plus I. Using the correct formula, you can solve the 1 plus I, subtract 1, you will get the I. It's the same quantity with a lot less Hilbert-Sum equation. I was going over the original formula for B3 and B5 and tried to check the relation. The final equation is kind of similar, very similar formatting. Any question? Were you okay? All right, so then we solve for the I. Once we finish identifying the I, the rest is the price, which equal to, right, the price is calculated at here. Price we want to find out is the total present value of all the future cash flow. And we already have B3. What does the P3 represent? Present value of all these cash flow. So then those are all calculated. So you're gonna discount 1, 2, 3. 3, that's the eighth. That's this one. So you want to find B3 discounted back to time 0. That's this one. And you want to find out this is the 80. And there's the 80. And there's that 80. So this 83 payment of $80, you want to find its present value. And then they add it together will be your price at time 0. Really, the price at time 0 is the total present value of all the cash flow. B3 already had a lot of the, all the rest of the cash flow. We only have to consider the first 3 cash flow that's not included in B3. That's why we have to add it into the price. Any question? You can see that it's actually lower than the B3 because this is a bond that's sold at a discount. And that is the solution for this question. So it's one of the discount scenario. Right, and then yeah. And then we're gonna look at how do we determine the amortization schedule for the bond payment. Okay, so we're not gonna finish all of them, but I'm just trying to explain the process of getting that schedule, the amortization schedule for bond calculated. Now this one is a 8% par value bond with face amount of 100,000 and semi-annual coupon payment mature after 4 years. Construct a amortization plan schedule, amortization schedule over its term if the investor nominal yield is 6%. All right, and then we should notice one thing is that this is par value bond. So if it's par value bond, then F equal to C. That means the coupon rate do not have to be modified. So G equal to 8%, and then the I is 6%. Okay, so then that means the G is higher than I. That's a bond that's sold at a premium. Are we okay? So that's why the title said writing down, because it's a premium situation. And we're gonna try to create the schedule. And here we are, the 100,000 is F and is also the C, N equal to 2 semi-annual payment, and then number payment is 4 years. Alpha equal to 8%, I equal to 6%. The 8% and 6% both has to be divided by 2. But still, you see the 8% is higher than 6%. Therefore, this is a premium situation, not a discount situation. Any question? So we're gonna see how the book value slowly going down from, slowly decreasing. And we don't have the price. We would look at the price calculation. F times R is our coupon payment for 4,000. The final redemption amount is 100,000. And then let's calculate the price. Price also equal to B0. B0 is equal to the 4,000 payment. You're gonna get how many payment? 8. 4 year half semi-annual payment. So it's 8 payments. So N equal to 8. And then the final payment also discounted for 8 payment. payment period. The J equal to 0.03 because that was the half of the 6%. And you can see a total value, which is obviously higher than the 100,000. Let's take 107,000 more. Any question? The same calculation can continue, but B0 is you have to have followed by 8 payment. B1 means you already paid 1 coupon, and there's 7 payment in the future, so that's that one. And then you can continue calculate B0, B1, B2, B3, which will be the book value. That will be the last column of the calculation. Let's say this is the amortization schedule. All right, we can certainly identify how to calculate this thing. The last column I already indicated how to calculate it. The last column is a book value calculation. It really is a present value of all the future cash flow. If you have all your book value calculated, book value multiplied by the interest rate is the I that in the interest column. So the coupon will always stay the same. There's no issue of how to identify the coupon. The I is really the book value, previous book value multiplied by the interest rate. That's all the I. So the I has been changing based on the book value is changing. And then you take your coupon payment minus the I, which is all the P. So the third column, the PT column, are calculated based on subtraction. We can certainly follow the other formula, the CG minus J, V to the, that could also work. But I follow the basic formula there. And there's also another situation called writing up, because in the question we have a par value on the interest rate being 8%, and we wanted to have a yield rate of 10%. 8% is smaller than 10%. That's why it's called writing up, because your book value will go up, 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 up. So it's going to be increasing function because this is smaller. The 8% is smaller than 10%. The coupon rate is lower than the interest rate. I didn't follow through the entire calculation, but that was the result. If you calculate the bond price is 93,000, which is lower than this. So it would be an increasing function. This is a redemption amount that is lower than the 100,000. Unlike the previous example, you have something higher than the 100,000, which slowly going down to 100,000. So this is what we call writing down. And this is what we call it writing up. And I think that's all the example that I had for 6.5. And I assigned homework on this. So we're going to start talking about how to identify book value. If you try the homework question, you can see the book value has a lot of similarity to what we were doing with 5.2. So I hope that you can follow your understanding of this section with more example. So the bond price and coupon rate relation, just to get us familiar with the bond alphabet soup, knowing all those letter and relation quantity. The 5.2 has a very similar reasoning. It's pretty much a present value calculation of all the future cash flow calculation. And with a loan, we can have the prospective and retrospective method, but with bond, I think the only good method will be the prospective method to calculate cash total present value of the future cash flow. And that should be it for today. If you have any question when you're working on the homework, you can identify that. We can work on those together. Okay, that'll be it for today. Thank you. Did I forget to count the class attendance? Oh, I think I forget to record. I was gonna do a quicker question. Did I not do it? I think I forget to do it. So anyway, it's out of time, but I remember Anthony, Keller, you, Natalie was online, right? So for today, I think what I remember is 4 students. That will be us. I'm probably gonna skip the later question because we're out of time. We'll do it next time. That'll be it for today. Thank you. Bye, thank you. Log out.
Can you tell what I did wrong?
You were, that same question, right? Let me see.
Because I tried it that same way.
You got 5 years, so the number of payment is 60 payment after making the first payment and 1 month from. Should begin skipping. Okay, did you calculate your P? So that's your total payment. Is the rounding okay? Is there any more?
The rounding went to. It was like 9.8 something. I think I tried it. I didn't save it.
Okay, it's okay. But assume this is okay, then the 3 month interest rate is there, and then you were supposed to calculate the total future value if you got 20 payments. So what you did is, you also have that 50 years. See, we have the same scenario. So that would be there, and then your interest rate end up being this, okay? That's your 3 months interest rate.
Yeah, I went ahead and just plugged that in
Mhm.
instead, so it'd be a little more.
All right, so your denominator should not be that one. Your denominator should be the 20. Is that? So I think your denominator, this is your J, right? Is your denominator for this. So your denominator should be this one, right? This one goes. But it's not that one. It's not that cute. It should be the, and you can calculate, it's not the same thing. This denominator is supposed to be 0.015075, at least.
Okay, that
Okay. Yeah, that one should not be it. This one should be.
also the same.
Right, I said that this supposed to be the 1 plus J to the power 20, but then you see your 1 plus J, you're gonna add the 1 to the other side. 1 plus J, it's 1.0005 to the power 3. If you raise it to the power 20, this is supposed to be 1.005 to the power 60 and minus 1. That's the numerature. So the way you calculate, if you have the cube inside there, it's gonna be a problem.
Okay.
Yeah.
Gotcha. Thank you.